Hello everybody, this is Michel Bakker. I think it's time to start our webinar. Just doing a short check whether my co-organizers are also in the call. Alex, are you there?
Yes, I'm here. Hello.
Okay, hello. Okay, so I think that's working. So welcome everybody to this online meetup and webinar on mobile application security. I'm Michel Bakker and I'm the organizer of this event. For those who don't know me yet, I'm the security thought leader for AppSec NL and also working as an application and security consultant at Netstone. And I'm also the moderator of the meetup group on application security and secure DevOps. So in this meetup group, we like to focus on sharing information about secure software development and secure DevOps, and also mobile security. And in the session for today, we will be talking about mobile security. I think this is at this point a very interesting topic, as last year we saw a serious increase in the market in reported security breaches in mobile applications. So we have a couple of interesting speakers for today who are experts in the field in mobile application security, and they are from the leading vendor, mobile security vendor Promon, and are dealing with app security issues every day, and have really interesting insights in what is going on and how to defend against these threats. So I really appreciate your taking the time to participate in today's online event. I hope you enjoy it. In this GoToWebinar, you have the possibility to ask questions, but you can do this via the chat, and we will try and handle them at the end of the presentation. So the agenda for today, you already are seeing it. I will give the presentation further to Alex Wimmer of Promon. After that, his colleague Morten Ruud will talk a bit more about strategies on attacks and how to defend. And the session will be wrapped up by Kruger, who is the CTO of Netstone. So, Alex, I'm going to give you the presentation, right?
Good.
Yeah. There you are.
Let's see. Here we are. I hope you see the slides now. So,
yes.
Also from my side, welcome everybody. I will be trying to speak loud and clear and not too fast. So, I'm very pleased that Netstone invited us over to talk a little bit about the market I'm in for approximately now 4 years, and it's a market which have its up and downs, but it's seeing through the last 2 years a huge increase of interest. So we're talking about mobile applications. So as you see, I want to go with you through a small journey about mobile applications and how to shielding it or how to protect it. So what they say, and I always think it's important to get a broader view on what do we mean with application protection or even mobile application protection. So on the one hand side, you see Gartner saying, okay, it's a market guide for in-app protection. You see another word. So we have mobile application protection, we have in-app protection, we have mobile shielding. Everything is the same. It's about protecting an application which are out in the world on an untrusted device usually. So what changed? So from 2018 to 2019, Gartner changed to one word in their market guide, and you see it with a green circle. It's a must. Before it was should, and now it's a must. So this means if Gartner say you have to do it, probably some of things think you have to do it too. On the other hand, you see that Allianz on the corner up right, Allianz is saying the business risk number one is cyber incidents. And that's very interesting. So the world is changing, and at the moment, as we all are facing our home office time, is changing again dramatically. It's going to be more digitalized. And in the end, you have an endpoint. And on the endpoint, it's running an app. And here we are again. So it's all about protecting little pieces of software which belongs to any corporation, which have Intel inside, which are broadly spread out in the world and public available by everybody. So that keep in mind, there's a little piece of software which have your brand on it, which have credentials sometimes in it, and sometimes they even not encrypted, which have connections to server in it because they're connecting to some servers anyway, are exposed out there in the world, and everybody can grab it and take a copy out of it. So, and now comes the thing, is this a risk? Yes, it is a risk. We have two examples over there. So if you go for the corner left one, you see the Air Canada breach, so you can Google that if you want to. What happened? The application got hacked and they stolen 20,000 credentials of passport and credit cards and things like that. And that's just something which we got known by the press. And there's much, much more in the market out there. But the most dramatical thing is the young lady down there in the right called Alyssa Knight. I met her a couple of times. Alyssa is a professional hacker, and she worked at that time for a company called IT Group, and she did something. She was taking 30 banking apps randomly, big banks, small banks, whatever banks, and 29 hacks were done in less than 8 minutes. And she were in the apps and can do everything and even can connect to servers backwards and forwards. So, and this was the one thing where I said, wow, there is really something we should do. So just to recap, it's about mobile applications, which are little pieces of software which are out there, which are exposed, which can be taken from anybody, which have all the information in there, sometimes to even come into your data centers. So that's what they say. And here's what we think. So applications have to be shielded. You have to ensure the app integrity at runtime, which means if you start the app, it's at runtime. Means there are actions, you can hooking it and whatever. Morten will talk a little bit later. And at rest, it means when the app is downloaded. So you can put it on emulators or debuggers and whatever tools you have. So that's important that you are protecting these apps on both events, at rest and at runtime. Good. Some more details about malware will come from Morten. But what we are seeing, and as the company I'm working for, Promon, is doing a lot of research out there, especially in malware, and especially in malware in the mobile world, mostly on Android. We are seeing a huge increase of things happening out there. Maybe I'll just jump to that slide. So one thing which we found was a now very popular situation called Strandhawk. Strandhawk was one of the malware we found, which was reported to Google, and we had to wait for a couple of weeks till we can announce it in the end. So here we are. We found Strandhawk. We can help against it. And what Strandhawk in detail is doing, Morten can tell you, but all over it's an account takeover. So when you start up an app, Strandhawk can over the account and look into everything you're putting into your system. So that was a quick overview about the market in itself and what is a mobile application, or why should we protect mobile applications at all. Do you have any questions so far here? No? And maybe we can jump to Morten.
Yes, we can do that.
Right.
So I will take over.
Yes.
Myself and see if I can share the right screen. That should be the correct one. Yes. So we pick up where Alex ended off. So quick introduction to me as well. I've been working in security in general my entire working life, in mobile security for 2 years, roughly now. but I've been working in security encryption world for more than 20 years. So Alex mentioned Strandhog. So Strandhog is something that was reported to Google by us last fall, and we went public with the details after more than 3 months waiting for Google. And it's a vulnerability more than a virus itself. It's a vulnerability that exists in every version of Android in the world. Without going too deep into what it is, and the reason we found it is because it's used in the wild. But it's a way for applications to abuse how Android implements multitasking by inserting activities into other apps or even pretending to be other apps to gain permissions. So it's a nasty one. It works out of process if you want to be technical about it, but it seems to be within process for end user. That's just one vulnerability out there. Looking at the mobile landscape in general, there are many threats through malware. Of course, the distribution of them differs, such as Strandhog we found through dropper apps. That was basically a normal app on the Play Store. I think it was a weather app or a PDF reader, which in reality functions as a dropper app, which means that after installing, it will basically start installing stuff from other places, which includes the malware. And then when Google finds the malicious behavior, they remove it from the App Store, but it's already distributed with a lot of people. This app targeted banks in particular. Other ways to distribute malware, of course, is sideloading or third-party app stores, typically by creating apps that look like valid apps, but are actually malware. And how do you recognize malware? What do they typically do to achieve their things? Accessibility service is a big one as an entry point for malware. Android Accessibility Service is a legitimate service for any app that requires text-to-speech, for example, for people with poor vision. But having that credential to your app also means you can read everything on the screen, which is the next point, screen readers, which can be used to read your banking statements or whatever you want to do to read everything that's shown on your screen is basically visible to the malware that has this accessibility. That in turn can be used to create fake windows, either via Strandhog, like attacks by basically injecting new tasks into your application. That looks exactly like you would expect it to do. You perform a transaction, you're actually giving that transaction to the attacker. Other features are, of course, keyloggers, which you don't even need with Strandhog because you basically own what's happening, or overlay attacks to fake phishing windows. And there's lots of different malware out there. Some of the current ones by name is Gustav, Cerberus, CommentBot, Exabot, and Basbanke. Many of these go for financial services, be that either a fintech or a banking app, because it's easy money, basically. They either really want the money or your ID, or both. So back to the topic of securing the mobile app. Why is that important? So I think a lot of DevOps and system operators are well aware of the importance of protecting your infrastructure. To have antivirus active, to have firewalls, email filters, and so on. What's commonly forgotten is the device that you're running your software on at the edge. Especially today in the work at home environment where there's a lot of bring your own device scenarios. How do you know that the session they are using, be that to your Office 365 account, be that through your remote desktop software, how do you know that that device isn't compromised? How do you know that whatever goes through the VPN tunnel to your system comes from the end user and doesn't come from malware on the device? Today you don't, typically. because what malware also does is basically code injection. It can expose data. It can as Alex mentioned from the mobile app testing or Monitor 2020 attack, you can use the app to basically go through a secure channel. So endpoint security is more than just a firewall or antivirus. It's really about the integrity of the process of the application itself to ensure that one is reverse engineering, which is typically done for IPR theft or code, for repackaging of it and reuse of it. But typically, when looking at this scenario, it's about code injection and modification to try to tamper with the behavior of the app. That can be, for example, to change all text you enter to something else. Simple as that, or to steal keyboard credentials. Or basically try to get through that secure app tunnel to learn more about your infrastructure. So we believe that it is important to harden the endpoint. You can verify the integrity of the endpoint itself. That's an enhancement to your network security. And you need to do that by protecting the binary code, your cryptographic keys, and also ensuring that nothing else is hooking into the process tree, that nothing else is manipulating the hidden part of the process and application, so to speak, the stuff which happens under the hood. Any questions or comments so far, by the way? Seems quiet. So a little
Morten,
bit
Morten, sorry, this is Michel. Well, you know, the attendees, they do not have the possibility to talk into the presentation.
No, I'm reading the chat.
And they can put questions up for answering in the chat.
So
Yes.
all right, please do that, and I will monitor the chat and see if anything's coming in.
Yep, I'm looking at it at the same time as well. So.
Okay.
Thank you. So continuing on the slide that Alex had about the importance of protecting your application both at rest and at runtime, I was thinking I would dive a little bit deeper into what that means and what that entails and why it's relevant. So if looking at the graphics here, that's a sort of a looking under the hood, so to speak, of a mobile device, where you have the applications on your launcher on the top there. The four icons are your applications, how they visualize on the mobile phone, and that visualizes a binary code, which is basically the application as downloaded from the App Store. It's the code at rest. It's the APK or the IPA as such, as was published by the publisher of the app. What you see below there is the runtime execution environment of the device. That means the operating system, the system drivers, the network components. It also means other applications, because these devices do multitasking, they do multiprocessing. So it's the really execution environment where the app launches, which in the perfect world is a perfect sandbox. We don't live in a perfect world. So protecting your code at rest is important for a couple of reasons. The classical one is reverse engineering and IPR theft or IP theft to steal your code. The challenge with that thought process is that when you publish an app, is downloaded, it's really difficult to protect your IP in that app because there are tools out there to find out what your app does. But I'm not going to dig into all of those tools, but another part of it is the repackaging. Repackaging is taking an existing app, modifying it in whatever way, typically malicious, for example, installing or adding a hooking framework to it or adding malware to it, resigning it and publishing it on a third-party app store with your logo and brand on it. The typical tool for blocking or protecting code at rest is obfuscation. Obfuscation is a good tool for this. Obfuscation is designed to make code more difficult to read by the human eye, make it more difficult to analyze, but still be quite feasible and easy for the device to execute the code. So the machine still understands what the code does, even if it's obfuscated. And it's a good countermeasure to have in your app. It makes some of the other attacks slightly more challenging, but it's not sufficient in today's mobile world. If you're looking at the runtime below the application layer, that's where you find, as I said, other apps. You also find other devices, one of them being emulators. So if your mobile app doesn't block the execution of the emulator, you basically open up everything your app does to the attacker, because they control the device 100%, which can be used for runtime reverse engineering and other things. It also has, as I mentioned previously, that's where the spyware is. That's where the Trojans are. That's where malware lies. They are at the runtime. And they use other things. Debuggers is typically a manual process, which is down at the bottom there, again, used to analyze your app. That's where they start. And these tools, they can perform tasks on your application, such as code injection. Code injection means that they have code they want to run in your app that can, for example, connect to your backend, can perform actions in the application without end users being aware of it, whatever the code wants to do, unless you protect against that, protect your process itself. Another typical one is the hooking framework, or hooking in general. And I really like to call that runtime repackaging if you're not a developer, which basically means that you are at runtime changing the behavior of the code that you put in there. A classical example from a pen test perspective is to bypass a routing check, where you basically identify what triggers it, you hook that, and you return a value that tells the app that I'm not rooted, I'm happy to execute. And that can be done on any sort of code in the application. Once you're hooked into the app, you can change any response from any function, any feature. Again, not necessarily something you want happening to your app, especially if it has credentials stored or anything like that. You can also hook into, for example, if you're storing things on the app that you think are encrypted, they can hook into that function and retrieve the data. The other malware, as I mentioned previously, are the overlay attacks, the screen readers. And screen readers are, well, it's not a problem from an app perspective usually. The problem is end users. We are so used to giving apps whatever they ask for, because every app asks for something else. So a lot of people just give any app that asks for accessibility services the rights to do that, which is one of the things you really shouldn't. People are better at denying GPS access because of their privacy concerns, because it's a lot in the news. But accessibility service is actually worse from an application security point of view. And to protect against all of these things, you need mechanisms in place, which are really what Gartner and others call shielding or hardening or other terms for it. So you need to shield it. And this is something that's sort of beyond best practice of coding, because secure development on its own doesn't give you these things. It's a dedicated sort of way of developing tools to obtain this. Another thing which is important from a security perspective is to ensure that the security element of your app isn't taken out, such as I mentioned, the hooking framework, where you can hook into the routing detection to bypass it, to bypass the security feature by basically telling it what it wants to hear and continue executing the app. Or if your security feature is, well, basically a library that doesn't do anything else, you can remove the library and the app is still happy. because most of these functions basically say, if I can't read it, I'll still continue executing. So ensuring that the security feature of the app aren't taken out and the app without the app breaking is also what we call app binding, to bind the security feature to the application to ensure that any tampering to the app means the app breaks. And so from Promon's point of view, it should also be any sort of a tool like this. I'm not going to spend time on the commercials here, but briefly, it has to be easy to implement these things as well. So implementing security for a developer is usually not the easiest task in the world. We've spent 12 years to make sure that they don't have to be on our tools. They are designed to be fast, invisible to the end users, have no impact on development lifecycle, and take away the need for the developers to be experts on app security, but rather focus on features that they need for the product to be successful. I think that wraps up most of my slides at this stage.
All right, thank you very much, Morten. Thanks for the very clear explanation.
I hope I wasn't too fast.
Yeah, well, that gives us more time to, to look at the others, look at questions from the audience. And
Yes.
Let's see. I'm just going to bring up a screen. Let's see. Can you see my screen now?
Yes.
All right.
Yes.
I hope that everyone that was not convinced until now that mobile applications need protection are now a little bit curious about the subject, and I hope that you've learned a little bit about the vulnerabilities that may threaten mobile applications. And I'd like to invite you to to put your question in the chat so that either to Alex or to Morten, they can dive a little deeper into the subject.
I see some questions already. So I see Gareth Feiler has a question about iOS vulnerabilities. Yes, there are. Traditionally, iOS has been considered more secure and more robust than Android. There's a few reasons for that. One of them being the way apps are signed by Apple and distributed. It's more difficult to obtain the app binaries from a device than on iOS than it is on Android. But there are jailbreaks on iOS, to put it mildly. And typically what opens up for malware or attacks or reverse engineering is the breaking the root of trust of the device. On Android, this is quite common to do to root your device because it's straightforward and Google doesn't really care too much. On iOS, it has been challenging to do so and you risk breaking your phone, but it's still done frequently. So although there's less, there still are, and there's tools to do jailbreak and also to try to trick the apps to think it's not jailbroken, such as Liberty or Liberty Lite, that you still want to be aware of. So not doing the commercials again, because there's just good reasons to allow your app to execute on a rooted device, because if you don't, you will lose out on a lot of your customer base and will get bad reviews. But being aware of the relative security of the environment and ensuring that these attack vectors are protected against is the crucial element. So to put it shortly, yes, there are iOS vulnerabilities. They are not as many or as prevalent as on Android. I hope that answered that question.
Right.
And then we have from AB a question. If more than 80% of vulnerabilities occurs in the app layer, would you say that those are preventable coding mistakes under control of development teams? Because OS ITC concepts are kind of out of control of your developer. Well, yes. So you have the OS top 10 that sort of are designed, are telling you the top 10 risks and their test suites against OS that top 10 when it comes to developing and designing your application. And secure coding and secure development is essential to make sure that at least you don't introduce vulnerabilities to the known vulnerabilities to the application yourself, such as bad encryption, bad I/O handling, and stuff like that. And what Gartner says, and we agree with, is that this sort of process of hardening an app goes sort of beyond a regular developer process because it's research intensive. For example, the Strandhog malware that we found, analyzing it, reproducing it, identifying what vulnerabilities you're using, and how to protect against it, that's a very massive research-intensive task. It took us a few months also to document it for Google, and then it took them another 3 months plus to verify it to us. So these things go beyond that. So sticking to the OS top 10 for the development also includes these areas I'm talking about here to ensure that your process isn't tampered with, although that's not necessarily within scope of most app developers or app publishers. There's third parties who help with that. I hope that answered that questions. That's an interesting one from the same person, I think. What in my experience gives the most insight in the internal workings of an app? If it's a static analysis, source code review, decompiling. Well, when I do my pen tests, which I do as well, I usually do a combination. First, I check how the app performs on a device I control. If they don't care about anything, I know I can do whatever I want. If it has reactions to some of the things on my device, I try to identify by decompiling the app or reading on Android the Smalley code what it does. I can usually bypass that either by removing Smalley code and repackaging the app and running it, and I'll get to the next stage. Or I'll use a hooking framework like Frida to bypass it and basically take away the runtime protection it may have. Most apps I've seen, they have root detection and that's it. And if you have root detection and no repackaging detection, I can remove that root detection by manipulating the binary itself, or basically unpacking the Smalley code and repackaging it. If I don't want to do that, I can basically hook it with Frida if it's in Java or in native. Robin Farmer, iOS apps, yes. Yes, as I mentioned before, there's challenges on both platforms. And with the I forget the name, the Rain something, the new iOS jailbreaks is becoming more popular to jailbreak your iPhone as well, typically for other reasons than for Android, because you want to change your font or whatever, or some icons. But it has the same impact. So yes, we have the same issues on iOS, although they are better at locking down things, forcing updates of phones. That's one of the biggest challenges on Android. I would say that there's so many legacy OS devices out there, while Apple discontinues signing images. Oh, okay. Those are questions and tasks. Anything I missed out on?
Yeah, I've got another question here, which is, if users want to jailbreak their device, or if they contract a malware, why should we as a mobile app developer care about that? I mean, it's their responsibility. Why should we still care about that and try to prevent that?
Well, it's really about the usage of your application. So depends on what your app does. If you are publishing a free-to-use app that has no sensitive data involved in it, that you don't need to make money on or protect credentials from, there's no reason to care. However, if you are publishing apps you either want to make money on or that you want to protect money on, such as a fintech app, or you want to protect credentials or have access your server side for communication, you want to be aware of the state of the device, if nothing else. You want to be ensured that you know the state, and you also want to be ensured that your application, even if the state of the device may not be perfect, it can be, for example, rooted, it can be jailbroken, you want to ensure that your app isn't tampered with while executing. You don't want people to be able to tamper with the process. And one thing is what a pen tester does, of course, but most of what a pen tester finds is scalable in malware, although it sounds a little bit weird, because it is possible to do so. Manually means it's possible to do it programmatically in most cases. So it's really about the app you want to protect and the value therein. So I wouldn't say app shielding is for everyone, just as OWASP top 10 isn't relevant for everyone. But if you're working on an app that has sensitive data or money involved, or server-side communication where you store other sensitive data, you should consider hardening your app.
Mm-hmm. Okay, thank you. And one follow-up question: you've studied a lot of attack vectors and vulnerabilities in general in mobile applications. Do you think it's possible that we will see ransomware on mobile devices in the future?
Oh, it's already there. Gustav is quite feasible of doing ransomware. Okay. So quite a few of the ones I mentioned, they have the capabilities to turn it on from the CNC center. We haven't seen many doing that yet, but there is capabilities in the malware out there. And these malware families are typically branches of each other or a combination of other malware, and they're all for sale. You know, the guys behind this are professional. They sell it as a rental model or as a one-off, and you have access to dashboards and command control centers and everything like that. It's a commercial business.
Okay. Thanks a lot. Well, I'm not seeing any more questions. I would like to remind the attendees, if you're not in the AppSec NL Secure DevOps group yet, please join us on Meetup. We are going to organize more of these meetups soon on different subjects. We will do more of these information sessions, and we will also do more hands-on kind of sessions, and we will definitely also look at a hands-on session in the near future where we look at strategies to actually protect against all these threats. So I'm really looking forward to seeing you in that webinar as well. And from my side, yeah, there's still time. I see that there's one more question. I think that one is also one for you, probably, Morten. Would you care to take this next question?
Sure. Let me see if I can see. Is it on top or bottom? Yeah, still time. Yes. Yeah, ransomware typically requires root access if you want to do the entire device. That's correct. The challenge, of course, is how do you know if a device is rooted? Because these guys work on a scale, they don't really target necessarily one by one. They have the, there are branches of malware that target individuals, such as the ones that were in WhatsApp. But typically they target anyone that downloads the app. And for that perspective, ransomware works fine. Because one of the things we've seen through the years is that some, I'm saying some, not all or not many, but some vendors, their phones are factory rooted or have root artifacts from the factory without the end user doing anything wrong. So it is still feasible to get that. And I don't have the statistics of number of rooted versus non-rooted Android devices out there, but it's quite a few, I would say. And there's a reason why root hiders such as Magisk are quite popular, because apps, everything from the Pokemon game to video streaming apps and others want to deny you access to their service if it's rooted, because it allows you to cheat. And people want to bypass that and still root their phone because whatever reason they think they should have access to breaking the sandbox. They forget that's what you're doing when you're rooting your phone, is breaking the sandbox. So it would still hit sufficient number of people to put it that way with ransomware. If you don't root your phone, you generally safe against a lot of malware, with some exceptions, and that's typically the ones that are abusing Android APIs, such as Strandhog, which definitely does that. And some screen readers and keyloggers can also work fine without rooting. Yes, that's one of the ones. Yeah, I see the follow-up there. Yeah, so there's some point root access, but so our tool does extensive checking for anomalies on the system, not just if there's a SU binary or stuff like that. We sometimes get questions from our customers again that say, "Oh, this guy says he never rooted his phone." We check the logs and we see what happened, and yeah, the phone was rooted even if it was freshly unpacked. You have full root access, although it's not easily visible to the end user. That's typically some of the Asian vendors, the smaller ones. This would not be a Pixel, it wouldn't be a Samsung, although they do other weird things. It doesn't necessarily do a root. My pleasure.
Thank you very much, Morten. I think if there are no more questions, I'm going to give back the word to Michel to finish up. And yeah, we're going to finish up a little early, and so that's great.
Thank you, Sander. Yeah, so this is the end of our presentation. I would say stay tuned because there's a lot more to come, and I would like to thank you all for attending. Thank you very much.